Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Iza binti Sabtu. In this video, we will explain about the definition of group and some examples. Okay, first, we should know that there are four properties or axioms of a group, which is closure, associativity, identity, and also the inverse. Okay, let's proceed to the definitions of group. A group consists of a non-empty set G together with a binary operation asterisk such that the following properties hold. First is closure. Closure states that take any two elements in set G and apply binary operations. Then A asterisk B should also be in a set G. Second, associativity. Associativity is where we move the parentheses around. For a general binary operation, we can say that we have open bracket A asterisk B asterisk C equals to A asterisk in bracket B asterisk C. Third, for identity, some element in the set and the element is called as E. In general, E is the identity. Okay, some element E such that X in G, E asterisk X equal to X asterisk E equals to X. The last axiom for group is inverse. For any element A in set G, there exists an element which is called A inverse or the inverse of A and also in set G such that A asterisk A inverse equals to A inverse asterisk A equal to identity which is E. Here is some simple example to help understand the definitions of a group. This is a set of a rational number under addition. Okay, so to determine whether this set is group or not, we check all the four axioms. First, for closure, if we add two rational numbers, we will get another rational number. Okay, for associativity, we can move the parentheses around and also we can get a rational number. Okay, third, for identity, the identity element is 0 because the identity element for under addition is 0 and 0 is a rational number. Last, for inverse, A equal to minus A. Minus A is a rational number. So, you can say that this set of a rational number under addition is a group because it satisfies all the
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Izzati binti Zainuddin. So I will explain an example for groups. So here is an example for groups. The question is a set P 1, 2, 3, 4 is closed under the binary operation multiplication modulo 5. Show that P multiplication modulo 5 is a group. So as we know, groups have four properties. So for the first one, we will identify the closure. So all x, y elements of P, A modulo multiplication modulo 5, B elements of P. Therefore, P is closed under multiplication modulo 5. So for the second one, we will take a look on the associativity. So all elements x, y, z is elements P. Then x in the bracket x multiplication modulo 5y multiplication modulo 5z is equal to x multiplication modulo 5 in the bracket of y multiplication modulo 5z because multiplication is associative. Therefore, multiplication modulo 5 is associative. So, for the third one, we will take a look on the identity elements. So all elements x is elements P. So x multiplication modulo 5 E is equal to E multiplication modulo 5x equal to x. Says A equal to 1. Then 1 multiplication modulo 5E equal to E multiplication modulo 5 1. Then it's equal to 1. Well, if we do A equal to 2, 2 multiplication modulo 5E equal to E multiplication modulo 5 2 equal to 2. While E equal to 1. So we will try for A equal to 3 and A equal to 4. Then we get E equal to 1. Therefore, E exists. E equal to 1 elements of P. So for the last one, we take a look on the inverse. All X elements of P. A inverse of 1 equal to 1. A inverse of 2 equal to 3. A inverse of 3 equal to 2 and A inverse of 4 equal to 4. Therefore, A multiplication modulo 5 A inverse equal to A inverse multiplication modulo 5A equal to 1. So lastly, we can conclude that P multiplication modulo 5 is a group.